Technology Evangelist podcast sponsored by Medidenta Digital. I'm Dr. John Fluke, and I have a really interesting and great guest today. It's Ayush Bagla, who is the CEO of Ackuretta, and Ackuretta is a 3D printing company. And since we're focusing on tech in dentistry, where better to start than with somebody that knows the technology and the 3D printing part of this inside and out. Ayush, thanks for joining me today.
It's a pleasure to be here, Doctor.
Thank
Thank
you.
you for having me.
No, you're well known in the industry. Ackuretta is obviously really well known. Let's start out with the backstory. Ayush, how did you end up in 3D printing, and give me a little bit of your path, your journey on how you got here.
Sure, I'd love to. So I started off with 3D printing about 15 years ago. My education has been in 3D printing. So, all through the engineering side with design and advanced manufacturing. During my education, I was working on metal 3D printing, more specifically on gold. So I was printing gold jewelry and certain other gold products. 15 years ago, this was like unheard of, right? That you could print gold. So yeah, I started off from there. And since my education was in 3D printing, as I graduated from college, I started looking into the business opportunities with 3D printing. And there I came across the jewelry vertical, and there's a component of dental as well. So pretty much jewelry and dental are similar in the respect of investment casting. Both are small size products, and both require making a pattern and then casting that into a final shape. So it was a very different industry back then because metal was more famous. And then through the years, we came up with new materials in 3D printing, and that piqued my interest to be more on the dental side and less on the jewelry side.
Yeah, that's really interesting how those dovetail. And I was actually going to ask you, did you know that, we learn how to work with gold? When I was in school, now that was a couple of decades ago, but a lot of what we didn't really work with a lot of aesthetic materials. We worked with gold, making, wax patterns and casting them and all that sort of thing. I'm fascinated with the whole thing of printing gold. Is it, do you do that molten? Is that how it's done? Or how do you print with gold? I know you can do it, but I have no idea how.
Well, just like some of the other printing that's done on, let's say, metal printing, it,
Mhm.
it would be there's a bed of powder, and it's gold powder, and then you have a laser, it's a heat laser, which melts the powder and sinters it into a 3D shape.
Okay, that's interesting. I was thinking you had to have, like a big vat of molten gold and somehow, it moved around. I didn't even realize it was done that way. And then you segued into dental. And you're right, because the jewelry vertical, I think, is very similar to dental in the small, intricate parts. They can't have mistakes. They don't have, I mean, they've got to have accuracy, because nobody wants jewelry that has defects in it. And certainly nobody wants dentistry that has defects in it. So can you talk a little bit about how you explored the dental field and what brought you to it?
Well, I would say back in 2014, we started getting more interest once the Invisalign patents expired.
Mhm.
And there was more number of small labs that were looking at producing models. And as they were looking to print the models and then thermoform them, there was a significant interest to start using low-cost stereolithography machines like a Form Labs or similar that could have those kind of on-site capabilities that typically otherwise required over $100,000 in investment and a lot of lab facilities.
So so you got a degree in what well, since it was over 15 years ago. What is your degree in? Let me just ask you that. It's just easier.
It was in additive manufacturing. So, it was focused on both the design and the manufacturing aspects. And on the design, it was how you can leverage 3D printing or additive manufacturing to make geometrical shapes that you could not do with traditional manufacturing techniques. And this is a computing subject, so it's garbage in, garbage out.
Right.
So the more design that you could do, uh, which was unique to this manufacturing technology, you leverage that power to actually produce it. So it requires knowledge of the manufacturing side to then make designs that could be produced using that technology.
Yeah, I remember reading an article, probably maybe it was 20 years ago, and I remember that they talked about in the military in this, that the Navy, the US Navy, was looking at putting 3D printers on aircraft carriers because they thought that if that way, if they needed a very specific part, they could print it. And I remember thinking to myself at the time, I was like, that's such a great idea, because obviously if you're at sea and you need, a specific part, it's got to come to you somehow. Somebody's got to either bring it to you or you've got to go in, and the expense of that I thought was crazy. But I didn't realize at the time when I read that, all I knew about 3D printing back then was, you'd go and go to hobby stores and see people, with their little extrusion printers that were printing plastics, and I wondered how they were going to do metal. And that's fascinating. You talk about the design aspect of things in dentistry has changed so much in probably the last 3 to 5 years. Where do you see it going?
The design is definitely the driver for this industry because the equipment and the materials will produce what the design is giving it as an input. And with regard to the design, I would say that AI, we live in the world of AI, as we know, is going to be the biggest needle mover as with the customizations that we are looking at. The marginal customizations that you see in the audio industry or in dental, all parts are similar but not the same. So the AI is going to be very effective in making high volume of designs possible. And if you can design more, you produce more.
I was talking to a young man last summer, and he was working for a dental 3D printing company in the industry. And I asked him I said, how did you get into this? And basically he was a little like you. He'd gotten an engineering degree in additive manufacturing. And he said, I got out of school, I was looking for a job, and my dad had a friend who was an oral surgeon, and said he and his dad's friend got together, and the surgeon was talking to him about printing. And he said, he was talking to the oral surgeon about how you can print plastics and all these sort of things. And the surgeon said, how about you come work for me until you find, a better job? So he did. And his whole job working for the oral surgeon was doing all on X dentures. And this young man he said, we'd get a patient in, we'd place the implants, we'd scan for him, and then I would design the denture. And it was like 10 years ago. And I said, how were you designing a denture 10 years ago? And he laughed and he said, with Blender. And I mean, I've played with Blender, and I can't make a circle in Blender. It's so complicated. And what I saw with this is the AI now, part of it has gotten so good. And that's one of the things I think a lot of doctors don't realize, is that I was at the American Dental Association it was probably 2016 or 2017. And there were, I don't know, 3 or 4 3D printer companies there, and they were printing things. And, they were amazing. But I asked them how they were designing, and they all said it was like, Blender or one of these other design softwares. And I think what happened was a lot of doctors that thought this is really something, they looked at it, and then when they realized, to me, Blender for design, and not you, I know, I know because you got the experience and you're good at it, but for the average person, Blender to 3D design to me is kind of like Photoshop for photography. There's so many tweaks and so many things you have to know that if you're not using it constantly, it's a use it or lose it thing. So one of the things I want doctors to know is that now that we've gotten AI involved in the design of this, when I started really looking heavily at 3D printing, it was during COVID. I started to see these design programs that basically were just, you just click next and the algorithms are doing everything for you. And from what you've said, I take it that's kind of where we're going, correct?
That's right. So the AI is taking the knowledge and the skill out of the normal process. And initially, it's going to be more like an assist where it gets you to a near final output as a clinician needs to sign off on it for it to be, let's say, compliant. And as time goes by, those number of steps would reduce and you'd get to an end result.
And that part of it, I don't know, it just blows my mind to think, what we're capable of now. I know with radiography 3D, or I'm sorry, radiography AI that we're using now, you can open your AI system and you can agree or disagree with different things it says, and it sends that information back to the servers and it learns from that. Is that being done in the design aspect of dental as well? If a system, let's say a system designs a denture, and there's one area where the doctor looks at it and says, "Now that is way off. We need to move it down here." Does the AI then communicate back and learn from that, or is that on a case by case basis?
Well, the AI is continuously learning. So whatever you put into it and process steps, it learns those incremental steps. And then with enough data size, it
Mhm.
starts automating those incremental steps.
So do you see 3D printing replacing the dental lab industry in the future? Bringing it all into the office.
I won't say it will replace the industry, but the thing is that it will definitely reduce certain tasks that are done by humans, whether it's at the lab or the clinic. And since we live in this AI age, it's dependent of the organization to realize that, okay, certain tasks can be automated and certain tasks cannot, because AI can only do certain soft tasks and the production tasks would still remain. However, you have another toolkit to increase your throughput with the current manpower that you'd have. And I noticed this when I went to certain labs in different parts of the world, that they were able to process 50% to 70% more cases by using more software tools, not AI, and then by using more production tools with milling or printing, depending on the case. So with their existing manpower infrastructure, they were able to increase their revenue significantly.
I can definitely see that. We're of the same opinion on that. I think you're always going to need a dental lab.
Yes.
There's just some things that a machine can't do. I mean, we see it a lot. I kind of think of dentistry with and AI a little bit like we see animation with AI. I was reading an article yesterday that over Christmas, Coca-Cola did a couple of video ads, and they did them totally with AI. And the original idea was people won't be able to tell. And they got a lot of flack from customers because when people watched the videos, there were certain things about the way the people in the video moved, or that they looked and how their eyes looked and all that sort of thing that the machine just can't render. And I think AI will get a lot better, but I agree with you. I think we're always going to need human beings in some part of the loop. I think maybe we'll see a contraction of the lab industry, maybe with larger labs because they can afford to make the investments in these kind of things. But I know that I've talked to some doctors that are concerned about the lab industry, and they're like, what are we going to do when we don't have a lab? And I always tell them, I think there will always be labs. Human beings,
Yes.
yeah, the creativity and the spark and aesthetics or whatever it is, I just don't ever see that being totally replaced. Um, do you see the other role of the lab as for simple things, maybe labs offering design services to doctors, where I've got a difficult case, I don't want to design it myself, but I've got the ability to print it here. Can you just do the file for me? Do you see that becoming more and more common?
Yes, I definitely foresee it in the same way. And I also foresee that certain cases that would be difficult for AI would continue to be at the lab. And I do see that smaller labs would either need to be a part of a larger lab organization, or they would need to focus on certain type of cases and certain other type of cases. They may start seeing a decline in case volume.
Yeah. Yeah, I completely agree with that. So let me ask you this. Accuretta is obviously one of the names that if you're into 3D printing in dentistry, Accuretta. Tell me a little bit about Accuretta and what you do and how you started and how you grew the company to the point that it is now.
Sure. So we started the company about 12 years ago. And initially, I started it in India, but the supply chain for this kind of technology is not so readily and easily available. So I relocated to Taiwan in 2015 and started out again, I would say from zero, more or less. And initially, we started building smaller units for stereolithography, which is your wet photopolymerization technology. And the technology was primarily DLP based at the time. And we were working on primarily the jewelry industry. And slowly we started seeing, as I mentioned earlier, dental applications coming through mainly for models. And in 2016, NextEnd comes out as this new hot thing with 15 types of materials. You can do temporaries, you can do splints, you can do guides, and that was like wow. So we looked at the industry as okay, in dental now it's 15 different business models, and in jewelry there's only two. One is casting and one is molding. So significantly larger market opportunity, significant more applications because you're looking at end products right now. You're not looking at casting, or you're not looking at intermediate products. You're looking at end products. And anything that's biocompatible commands a premium.
Mhm.
And our reading on the industry and its transition to move from like non-biocompatible to class one to class two was spot on. And we've seen it as three phases of growth. So primarily up to 2020, it was more non-biocompatible and then class one with like surgical guides.
Mhm.
And then after 2020, we started seeing more materials with Keystone coming in with the splints. Nextent MFH doing extremely well on hybrids and with Crown and Bridge. And then the denture solutions also started picking up because the softwares for dentures started to mature. So we've seen that evolution, and now 2025, we've seen that, okay, it's moving to the next phase where you've seen innovative materials from Pagdent, where they're not only producing the resins, but also the finishing materials. So stain, the glaze, the bonding, the luting cement, things like the soft reline kit that they've launched. And that's what we saw was the problem for the last 5 years, that the users didn't know what they needed to do to get a final product that they could say, okay, this is sellable. So the 3D printing was uh, somehow only providing an intermediate product that still required a lot of processing to be make it market worthy. And that's where we see the next 5 years of focus for the applications and the industry as a whole.
That's really good. I like that. And once again, I agree with you. We think a lot alike on these things. Um, where do you see, you mentioned all the resins, and it is amazing that, like you said, it seemed like there were one or two resins, and then suddenly the market just exploded, and there are resins for, gosh, almost every application. Do you see that there's going to be progress in the resin industry as well as the hardware of the printing?
Oh, for sure. And the thing that I noticed is that for the last 10 years, um, the resin manufacturers were just depending on what hardware is available and most commonly sold, like some of the stuff that you have in your background.
All right,
And then they use that to develop materials. However, those systems themselves have their own limitations. And the moment the material company, or maybe it's one company that has the ability to develop materials and hardware, would be able to remove some of those constraints from the hardware and develop custom materials for printing systems that could do more than what an off-the-shelf system could do. And with that, they could have a certain advantage on certain applications that they were developing. It would be more than what's currently possible with an off-the-shelf product.
you mentioned Pactent and their Sculpture 2 resin with uh, with the zirconia in it is pretty impressive. Um, do you think? Let me ask you this: I've had people ask me things like, "Well, when will we be able to print zirconia?" And I'm always like, "I have no idea," because all I know, all I know is really about the plastic side of it. Since you came from the jewelry side of it and had the metal side of it, how far away do you think we are from actually printing metals in this industry?
Uh, there are companies that are already printing metals with polymer in the matrix, and it's a mix. However, there's certain safety risks because those metal components are highly volatile because they're highly reactive. Anything with small spherical surface area is highly reactive to external environments, and those could lead to some serious issues. So, not so simple from the safety point of view. And sure, certain things could be done to negate those kind of problems. um, Metal printing for crowns is being done with laser sintering and the laser melting, as I had mentioned. We're seeing a lot of new innovations coming in from China, where you're able to print on tabletop 3D printers in metal crowns, and you're looking at, let's say, a buy-in capex cost of below $50,000, which is not very high, and you could
Right.
produce a significant amount of crowns. But let's face it, that if you want to replace an existing technology, today zirconia has become very popular, as we can agree. And you could buy a zirconia milling machine for below $20,000 from a
Right.
reputed manufacturer with very high-end aesthetics, with the multi-layer, and with all the marketing that's going behind zirconia with milling. And that's going to be difficult for 3D printing to topple. So even though I'm in the print side of things, I don't see it being very easy because the material of, like, in milling, you're using a compressed material, and that will always have certain mechanical properties that a loosely bound material in a liquid bath can not easily accomplish.
It's interesting that you say that because, as you said, I've got printers all over the place here, um, but I also have a mill, and there are definite, I think, applications um, for milling in dentistry. And I didn't realize the science behind the volatility of the metals and stuff. It's one of the reasons that I talk to people like you. Um, but that is intriguing to me because I could see, especially with the cost of the mills, like you said, being as low as they are now. that I can see dental offices doing both, milling the things that are, are easier to mill that, like you said, are, either zirconia is either, pre-sintered, which is what I use. It takes about twice as long, which is about 20-25 minutes to mill one crown, as opposed to an unsintered zirconia, which you can cut a lot faster, but then you've got to go through the sintering process yourself, which I think is, I like the trade-off of a few minutes of milling versus the time it takes to, heat the metal and do all those sintering things. I know when we take it out of the machine, we can just basically it's design, mill and deliver. We don't have to go
Yeah.
through any kind of glazing or sintering, which makes it pretty easy. How about metals for like removable partials, or the other thing? Are you familiar with Valplast at all?
I am.
Okay. Do you see that we'll get to the point that we can maybe not print metal frameworks? Because really what I feel like is I feel like Valplast has gotten so good and so reliable that for the majority of cases, doctors are more than willing to go with a flexible option as opposed to, a metal framework with acrylic. Do you think that we'll be able to print something akin to that? I always tell my patients that when I discuss Valplast or one of the other competitors with them, I always say it's like Tupperware. And the patients get that, which is why I say it, because they understand that, food containers are flexible and that they're plastic. And so do you see development in that area as well, to the point that we'll be able to print those kind of flexible partial options?
Very good question. And honestly, like I would say this is the year of partials because Keystone launched something with carbon for RPDs, and DTAX launched something as well. They look very promising. Of course, the more you test it, the more you use it, the more field data is out there to tell you how viable it really is versus, how much uh, of marketing it is. So
Right.
I think the proof is always in the pudding. But I can tell you that there's a push from more than a dozen resin companies who are about to release or have this in their product development pipeline.
And see, that I think is key. Um, what we got to, as you know, is that with surgical guides, I mean, if you have a good system, you can basically talk to a patient about doing an implant on Monday morning and seeing them to do the guided surgery on Tuesday morning. Um, I think that what would be a huge boost is to be able to have someone come into your office missing teeth on Monday morning, and then Monday afternoon or Tuesday morning
Yes.
handing them a finished, flexible partial, and solve that problem so much faster.
Totally agree. I mean, I think most companies have been focusing on, final crowns and permanent crowns and the marketing that goes behind it. But in reality, the RPD with the volume of users and the volume of requests that we get for that specific application is significantly more. And we think that that's a big market gap. And milling is, of course, catering to that market to some extent, and traditional Valplast, of course. But it's a perfect application for 3D printing, considering it's got an organic shape. And printing excels when you have to produce that organic shape. That's why you don't see companies easily producing like an iPhone case as a business with the VAT photopolymerization machine. It's just the technology and the product market fit.
Interesting. I could even see using flexible materials, even for surgical cases where you've got, you're removing a tooth, it has to heal. And rather than making hard acrylic to replace that tooth, especially in the anterior, I would almost rather know that I've got something a little flexible that has some give in it that will, give when the patient chews, and that sort of thing. It's interesting what you said about the organic, shape, that it works better with that. Is that just kind of a limit of the technology, or why do you think that is?
Yes, there is a certain limit with the technology. So it's not the most suitable technology to make square shapes and square parts. There are other additive technologies that are more suitable to that. And this is why the VAT photopolymerization technology, just the way the material shrinks, just the way the process is more suitable for audio components, jewelry, engineering parts, that have these kind of creative shapes. If you've seen those carbon videos from a decade ago, it was always like a mesh ball, and then
Yes.
right? But they
Yeah.
never usually showed you like a square frame or like an iPhone case or something that you tangibly use in your day-to-day life. For those, the filament printers with FDM are, let's say, more suitable. And that's in why there's a technology application fit with this VAT photopolymerization in dental because everything's organic and you're not producing products in mass because there's no two teeth in the world that are the same. So since there's
Yeah.
no, right,
Yeah.
everything's similar but not the same.
That's, what's funny is you talked about my 3D printers on the floor in front of the white one. It's actually covered with a bag so it doesn't get dusty. I have an FDM back there too. That's how I started. I didn't use it for dental. Um, but I was fascinated by what it could do. And so I bought it off of Amazon. I had to assemble it myself, which was took a whole day and was actually kind of fun. You would have probably loved it. Um, but I still print, little toys. I actually 3D print sometimes little things for kids and, mass produce them. And then when I'm talking to their parents about 3D printing, I'm like, well, we made this, kind of a thing, um, which I think is good marketing for the technology. Um, do you see the accuracy of printers getting better? I mean, I know that we're down. I read recently that it's down to around 35 microns. I don't know if we need to go any lower than that. Do you think that's even possible?
I don't think from the hardware side, getting a more accurate panel is going to make a significant difference. The pixel size, what you're referring to with the micron,
Yeah.
is at this point will assist more with the smoothness of the product
Okay.
rather than the accuracy of the final product. Because
Okay.
believe it or not, most of the parts, they only have 20% of the curing on the printer and there's 80% in the post cure. So there's a shrinkage that takes place in the post cure that's larger than when it's at the cure. And the shrinkage at the post cure is so much more that that actually dictates the end result significantly. Let's say it impacts the end result more than what the printer does. So it's a lesser known fact, but the post cure is more a component towards accuracy than the printer itself.
That is a lesser known fact. I knew you had to post cure. I had never heard that number before. So that really tells me something. Speaking of post cure, let me ask you about this. Is your opinion low oxygen or nitrogen based curing, or do you think that the devices that simply use a really strong, putting the light in from all sides, do you think that which way do you think is better?
So it's a good question, but I'll take a reverse approach on that.
Sure. Okay.
It typically depends on the material,
Okay.
and every material has been designed to work very differently. And this is where I feel in the next few years we will see new development, because the hardware will be made according to the material, not the material suiting the hardware. So if you look at a typical curing box, there's hundreds of materials that are being cured on it. And
Yes.
everyone has a different philosophy, a different application, and a different requirement from the material in terms of its mechanical properties. So transparent materials versus opaque ones, hard ones versus soft ones, or materials which have a little bit of give, like we're talking with the RPD. All of them require different performance on the post-cure side. So I do believe that there's going to be a lot of improvements on that end. because the material companies are going to dictate how post-cure is going to work.
That's interesting. Yeah, it's funny. I really hadn't thought about that. But it's so true. We'll probably, right now with your post-cure boxes, most of them, uh, you cure for 15, you cure for 20, you cure for 25. I can definitely see maybe different wavelengths or different, I don't know, different things that they'll be able to, then you'll dictate, this is the material and it will adapt to that. That's really cool. And this is why I want to have people like you to talk to, because basically what I did was I just dove in and started designing and started printing, and I pretty much I learned from scratch, but I don't have any formal education. I love getting people like you to talk to who have that, that background knowledge. I always say that, the thing that I do clinically is, a lot of it is hand skills. And I can humorously say you could teach a monkey the hand skills, but the difference between the monkey and the human is the human knows why it's important to, only come from this angle, or only why to use this material. And you could someday have a robot that does dentistry, but the robot's going to have to know, why am I doing this? Why am I using the materials and all that sort of thing? So I love getting the whys on things. It's just really fascinating. So let me ask you, what do you think the next big thing is for Ackuretta?
Well, the way we see the industry going is you're going to see a combination of technology and tradition. So dental's been a very traditional business for many years, and the technology companies come in and they're like, okay, this is how it should be, this is how we would like it to be, but that's not how the dental industry works, because they have a very specific way of working. So it brings us to a new era of dental technology companies, and that era is what's going to drive the digital dentistry of tomorrow. And what we have lined up in the future is how do we use AI, not only internally in the company to improve our business, but how do we make that AI accessible to the users? Because we all know that most of the users, as clinicians or lab technicians, they want to get more done with less effort and less skills. So that's the biggest problem that we are solving, because they are the customer. And we see that the next biggest needle mover is with the materials and the overall workflow to create applications that currently haven't been seen. So in the last 2 years, everyone's talking about permanent crowns and permanent dentures, but there's so many more applications that we haven't been looked at with digital dentistry. And you're going to see some applications come to the market every year, and each of those applications are 9-figure, 10-figure opportunities for every company. So we have a vision what these applications are, and it's not just producing the 3D print, but there's going to be a lot more to process it and get it into real practice, and dentists keep using it. So our focus is to actually deliver on those new indications that are today not in the market.
That's good to hear. I love innovation. Ayush, thank you so much for spending some time with me and sharing your knowledge. Gosh, I know people are going to get a lot of info out of this episode, and I'm so grateful. Thank you very much for joining me, and I will talk to you soon on the Technology Evangelist podcast. I'm Dr. John Fluke. Thanks for watching.
Thank you, Dr. Fluke. Pleasure to be here, and appreciate the opportunity to speak to your audience today.
Thank you very much. Beautiful, Ayush. Wow. that was phenomenal. I didn't know your background, and I knew you were CEO and I knew you knew about 3D printing, but I had no idea about your university degree and all that. That is fascinating to me. the whole, I kind of got chills. The whole thing of I started out with jewelry and then jewelry took me to dental. It's so funny because a lot of dentistry is jewelry. I mean, it really is, the whole, wax.
Artwork.
In fact, it's funny. I know that I don't know if very many people use them. You probably know better than I do, but I think one of the first things I heard about Sprint was they were, making castable resins that were, it's like printing wax basically. And I thought, well, that's a nice start, but it's got to go better. But it's just it's just really interesting. Thank you so much for sharing that knowledge.
No, most welcome. I mean, there's a lot more. It's because it's more than a decade of work, and
Right.
as a company, we've not seen the dividend for the work that we've done in this
Right.
field. We've
Yes.
come out with a lot, nitrogen generator for some of our products recently. Before that, the world's first AI cam software. We invented these mini plates. Rick Ferguson copied those plates from us. That was something me and the CTO made. Before that, we were the world's first dental LCD printer that came out in 2018.
I didn't know that. I knew you were one of the
Yeah,
first. I didn't know you were the first. Congratulations on that.
but we never got the recognition or the credit for all these things. So
Right.
it's maybe it's because those are like small tools. Feel like in the dental market, what they really value is you get to the you disrupt the application, not just innovate on the tools that get you there. They value
Right.
the application. So now we're changing that, and I look forward to using some of these, leveraging some of these new applications to really come on stage one day and say, hey, like we came up with this new thing, and this treatment, you used to do it in a certain way, and now this is possible. It doesn't need to be these invasive treatments because those require like a lot of proof, a lot of
Right.
uh, back and forth, a lot of, I
Yeah.
don't know, there's just a lot. But if you don't require that, you could just uh, get it passed through or people to adopt it more easily, readily. Uh, that's where I see this technology be like, okay, now uh, we're looking at a space where everybody thought, oh, okay, there's no more. Uh,
Right.
there's a lot of people that I meet, they don't really have a vision.
Hmm.
So they just think that what's there is there and there's a little bit more after that, but they don't really understand how they can solve a market and an application problem. And sometimes it, even for us, you get caught up in our daily operation and, we lose sight of that. But I could foresee that there's a lot in that direction. And we will see that in the next few years.
Well, I think the dentistry with this whole thing of digital, because CAD CAM has been around so long in dentistry, and it's always been, you can mill a crown, you can mill a crown. I mean, I graduated from dental school in 1987, and one of the last crown lectures that I had, they said we've heard about this thing in Germany, and we don't even know what it's called, but it's like a robot and it cuts a piece of porcelain down and makes a crown. And it was CEREC, but I think dentistry has gotten, because that came to market first, and that's what people think of when they think of in office. I really think that dentistry needs to, like kind of what you said, expand the horizons.
Yes.
They get so caught up on that, can it do a crown? Can it do a crown? Can it do a crown? And my feeling is it can do a great intermediate crown. Um, but I don't think you can print things that you could put in someone's mouth and say 20 years from now, this will still be there. But that seems to be the focus of a lot of people in the industry, is it's got to be a crown. And I think it's just because we've been talking about crowns in office for so long that, you're we've all seen those videos where they do a distraction and then something happens over on the side or in the background and nobody sees it because they're watching, what's going on in front of them. And I think that's really true with a lot of this. Ayush, I can talk to you all day. I know you've got to go. I know you've got a meeting. So um, thank you very much. I really appreciate you doing this. I'm really grateful. All right. Thanks, Ayush. I appreciate you putting up with me.
No worries. Thank you, doctor.
All
Have
right.
a lovely
You
day.
bet. Thanks.
Thank you, Nikki.